This is MC 3.1 experiment, which is the determination of gas constant and molar volume of gas at STP. After completing this experiment, students should understand the concept of stoichiometry better, know how to determine the molar volume of gas at standard temperature and pressure or STP, and how to find the gas constant or the R value. As you have learned in the lecture, the ideal gas law is PV equal nRT, in which P is the pressure in atm, V is the volume in liter, T is the temperature in Kelvin, N is the amount of gas in mole, and R is the gas constant, which has a value of 0.08206 lit atm per Kelvin per mole. From this ideal gas law, if we keep the amount of gas constant, then we get the equation PV over T1 equals PV over T2 equals nR, or P1 T1 over T1 equals P2 V2 over T2. This is called combined theory of gas, and it is very useful for many calculations relating to gas. You probably have heard about STP. It is the standard temperature and pressure, and the pressure is 1 atm, while the temperature is 0 degrees Celsius or 273.15 Kelvin. You can use either 273.15 Kelvin or just 273 Kelvin. Either one is fine. In this experiment, we will use nitrogen gas because it behaves similar to ideal gas. We will produce nitrogen from the reaction between sulfuric acid and sodium nitrite, according to this equation. Sulfuric acid is chosen as a limiting agent because it has high molecular weight. So even when we need to use small amount of mole, it's still easy to weigh. Another reason is that it doesn't absorb moisture, so we can be sure that the amount we get is quite accurate and doesn't contain moisture. On the other hand, sodium nitrite is not good as a limiting agent because it has low molecular weight, and it also absorbs moisture, so we will use excess of sodium nitrite. From this equation, 1 mole of sulfuric acid will give 1 mole of nitrogen gas. If we keep the amount of sulfuric acid constant at 1 mole and use excess amount of sodium nitrite, no matter how much sodium nitrite we use, we will only get 1 mole of nitrogen gas. You will receive a solution of sulfuric acid that has already been prepared. You need to record its concentration. To determine the amount of mole you use, you can use this formula: concentration in molar or mole per liter times volume in milliliter divided by 1000. Dividing by 1000 is simply for converting from milliliter to liter, since the concentration is in liter. You will do the experiment twice, and for each time, get 25 milliliters of sulfuric acid solution from a burette. Again, record the concentration of this sulfuric acid solution. You will also need to prepare sodium nitrite solution by weighing about 0.6 to 0.7 grams of sodium nitrite in a beaker. Then dissolve it with 20 milliliters of distilled water. Stir it with a stirring rod to make sure that it all dissolves. Let's watch this video clip on how to weigh sodium nitrite. You need to set zero or tare the weight of the beaker first. Then get the amount you need. Then record its weight. Add 20 milliliters of distilled water using a graduated cylinder. Since we will be using excess amount of sodium nitrite, You will notice that we are not using a volumetric flask to prepare this solution. Stir the solution with a glass stirring rod until all sodium nitrite dissolves. Then transfer 5 ml of sodium nitrite solution into a glass vial using a graduate cylinder. Notice that we already tied the neck of the vial with a thread. Keep the remaining sodium nitrite solution for the second experiment. This is how we set up the experiment. We will connect the suction flask with a plastic or rubber tube and insert one end of the tube into the end of the inverted burette, which is immersed in a tapped water container. We will fill the burette with water by using a rubber bulb to suck the water up. If we cannot put the end of the tube into the burette, we might use a bent glass tube. The amount of water inside the burette should be about 40 to 50 milliliter. Read the starting volume of water. Read the volume at the meniscus. The end of the rubber tube is connected to the side arm of the suction flask. Pour 5 ml of sodium nitrite into a glass vial and put the vial into the suction flask by holding on the thread. Be careful not to knock the vial over. The thread inside the flask should be quite loose so that we can knock the vial over later. Push the stopper into the mouth of the flask tightly and apply plasticine so there is no gas leak. Again, be careful not to tip the vial over before you start the experiment. Cram the burette in a water container. Use the rubber bulb to suck water into the burette. You might need to do it several times until you get the water to the top. Notice that we press the bulb before inserting the burette into the bulb. Next is how to obtain sulfuric acid from the burette. For the burette, you can read up to 2 decimal points. You need to take 25 milliliters. Connect the suction flask to the tube. Put the sodium nitrite vial into the suction flask. Cap it with the stopcock and apply plasticine around it. After inspecting all parts of the experimental setup, gently agitate the suction flask to knock the vial over to mix sodium nitrite with sulfuric acid. Nitrogen gas will be produced and flow into the burette to replace water inside the burette. Check the suction flask to mix the solutions. Notice nitrogen gas flowing into the burette. When no more gas is formed, you can stop and record the water level. This is about 25.30 milliliters. Measure the height of water in the burette from the surface of the water in the container. Record the water temperature. Check your significant figures. When no more gas is produced, record the level of water remaining inside the burette, the water temperature, the height of water in the burette from the surface of water in the container. For your calculation, use 755 millimeter of mercury of atmospheric pressure. Repeat this experiment one more time. You will need to dispose the solution inside the suction flask and get sulfuric acid again. You will also need to suck up the water inside the burette again. Use this equation to calculate the pressure of nitrogen gas. pH, or the pressure regarding to the height of water level, you need to calculate from the fact that if the water height is 1033 centimeters, the pressure is 1 atm. For pressure of saturated water vapor, it depends on the temperature that you perform the experiment. Here is just part of the table you see in the lab manual. If the temperature is not a whole number or integer, you will need to calculate it based on the pressure of the nearby numbers. The gas constant can be calculated using this formula. After you get the experimental gas constant, you will need to determine the percent deviation of the gas constant. Note that the theoretical gas constant is 0.08206 lit atm per mole per Kelvin. You will also need to find the volume of nitrogen gas at STP using this equation. After you get the volume of nitrogen gas at STP, then you need to find the molar volume of gas using the number of moles of nitrogen gas. Then find the deviation of this molar volume of gas at STP compared to the theoretical value, which is 22.414 liters.